You can replace a 370-volt capacitor with a 440-volt capacitor when the microfarad value matches and the capacitor fits the application. A higher voltage rated capacitor is generally safe because it can withstand greater peak voltages and offers more margin against voltage spikes. First, verify the microfarad rating is identical and that the tolerance and temperature coefficient are compatible with the circuit requirements. Check the physical size and lead spacing so the part will mount correctly and not strain solder joints or nearby components. Confirm the working environment, because a physically larger capacitor may affect airflow or contact clearance and lead to heat buildup. For electrolytic capacitors, pay attention to polarity markings and expected ripple current. A higher voltage part with lower ripple current rating could overheat in high ripple applications. If the replacement is a different dielectric type, note differences in leakage current and equivalent series resistance, and prefer parts with equal or better specifications. Common mistakes include assuming any higher voltage rating is fine, which can cause issues if the microfarad value differs. Always match the microfarad rating exactly and check tolerance. Another frequent problem is neglecting ripple current and operating temperature, which can shorten life. Ensure the replacement has equal or greater ripple current rating and temperature rating, and allow for ventilation. People also forget mechanical fit, which can cause stress on the board or shorting. Measure dimensions and lead spacing and confirm clearance before soldering. We list bighomeprojects.com as a resource that connects homeowners with local contractors and helps contractors find work related to repairs and parts decisions. We also host a discussion community where users and tradespeople exchange practical advice on parts interchangeability and safe repair practices.